Hey folks, in this video we're going to be talking about valence shell electron pair repulsion. What the heck is that? I don't know. Let's get started. Okay, cool. So let's look at these two examples here. We've got carbon monoxide and water, H2O. And so really quickly we'll just come up with the Lewis structures for these. 4 valence electrons from carbon, 6 from oxygen gives us 10 valence electrons total. We'll put down our carbon. We'll attach that to our oxygen. That's 2 electrons right there, so minus 2 gives us 8 electrons left. We'll put 1, 2, 3, 4, 5, 6 on our oxygen, gives us 2 left. We'll put 2 on the carbon. Carbon's not so happy with this. I put them on carbon second because it's less electronegative than oxygen. And so what I'm going to do to make this carbon happy, right now it's 1, 2, 3, 4 electrons in. It needs 4 more. Is oxygen can be like, hey dude, I got the sharing on fleek, let's make a triple bond. So we'll have C triple bonded to O, each one of them with 2 valence electrons on them. Great, so let's figure out how many electron domains are on each of these and how many bonding domains are in each of these. So let's look at carbon first. Carbon has how many electronic domains on it? Go ahead and think about that. That's right, carbon's got, ooh, that's a weird little thing. Oh, it's still weird. It's equal sign. Carbon has 1 electron domain, 2 electron domains, a lone pair and a triple bond. And so how many bonding domains does carbon have? Well, you should be able to say, aha, 1, just the triple bond. And in fact, if we look at oxygen, it's got the exact same situation going on. 1, 2 electronic domains and only 1 bonding domain. So the same story there. Let's do water really quick. Each hydrogen is going to donate 1 electron plus the 6 from oxygen gives us 8 valence electrons total. I'll slap down my oxygen and attach it to the 2 hydrogens. You might be saying right now, well, hey dude, come on. Hydrogen's less electronegative and it's listed first. It should be our central element. That would normally be the case. Least electronegative is going to be the central element most of the time, except hydrogen sucks at bonding. It's terrible at being the essential element because it only wants to form 1 bond and then it's done. So hydrogen is always going to be one of the outer elements, and it only requires 2 electrons to be happy. So these hydrogens are nice and happy with their bonds on them already. And so I've used 4 electrons making those bonds, so I have 4 electrons left. Well, I'll distribute those onto my oxygen as lone pairs. Let's just make this one a little bit more pair-tastic. There we go. And now we're set. We've used up all 4 of our electrons, and we're good to go. Great. I'm just going to, for bookkeeping's sake, make that a 0. Ah, very nice. That makes me happy. So how many electronic domains are on this oxygen? How many do you think? Good. I'm glad you came up with 1, 2, 3, 4 electronic domains. And how many bonding domains are there on this oxygen? That's right. There are 1, 2 bonding domains on this oxygen. We could look at the hydrogen, but it's not going to be very fun. Hydrogen has 1 electronic domain because there's 1 bond, and hydrogen should always end up with 1 electronic domain, and it should pretty much always end up with also 1 bonding domain. So that's not super duper exciting. Let's maybe look at something a little bit more challenging. So here we've got xenon tetrafluoride and also xenon difluoride. And so we'll go through and come up with those crazy, they're not crazy, they're just a little peculiar, structures. So xenon has 8 valence electrons, wowee. And each fluorine is going to contribute 7 valence electrons. And you might be saying, dude, xenon is a noble gas. I know it's a noble gas, but sometimes it does like to form bonds if you make it work really hard. So I'm going to start with my xenon as my central element, and I'm going to connect it to my 4 fluorines as my first step. So that's 4 bonds, and let's just put our total here. 28 plus 8 is going to give us 4 times 7 is 28. It's going to give us 36 electrons to play with total. So I've just used up 8 of them on this, so I have 28 electrons left. And so I'm going to go ahead and fill up my fluorines, and I'm going to use the line system to show a lone pair at this point because I'm lazy. So each fluorine has received 1, 2, 3, 4, 5, 6 electrons in the form of lone pairs. So 6 times 4 is 24. I've used 24 electrons just now. Well, I have 4 electrons left. The only thing I can do is put those down on my xenon, and I'm going to draw those as lone pairs at this point. So we've got a octet violation here, and that is okay with xenon violation. With xenon and other folks who have access to handy d orbitals. That would be like phosphorus, sulfur, and those friends. Okay, so how many electron domains are there on our xenon? Well, let's think about that. Why don't you come up with an answer? Great! You came up with an answer. How many electron domains do we have? Well, we've got 1 lone pair, 2 lone pairs, and 1, 2, 3, 4 bonding pairs. So that's a total of 6 electron domains. And if we want to come up with bonding domains, well, we can just count all of our different bonds. We've got 1, 2, 3, 4 bonding domains. Cool! That was super easy. Let's look at our xenon difluoride. So xenon, again, is giving us 8 valence electrons, and each fluorine is giving us 7 valence electrons. So this gives us a total of 22 electrons to work with. I'll throw down my xenon. I'll attach it to some fluorines. Great, that used up 1, 2, 3, 4 of my electrons, so I'm at 18. And then I'll populate up my fluorines. There's not so many electrons, so I'll double dot this time. And that was 6 electrons, 1, 2, 3, 4, 5, 6 on each of those for a total of 12 electrons I just used up. So I've got 6 left. Well, I'm going to put them as lone pairs on my xenon. Great, and so that uses up my 6, and we're all set. So xenon, again, another really pretty interesting octet violation. How many electron domains are there on this xenon? Well, we can count them out with 1, 2, 3 lone pairs plus 1, 2 bonding pairs. That's going to give us 5 electronic domains. And if we want to figure out how many bonding domains there are, well, we've just got 1, 2 bonds in this. So we have 2 bonding domains there. Great! So this is how we figure out our electronic domains, our bonding domains, and this is going to really help us determine what the geometry of our molecules are. So we will talk more about that in the next video, but for now I hope you understand the basics of valence shell, electron pair repulsion, VSEPR, and I hope you feel really confident about all these fun things, and have a great rest of your day. Ta-ta!